Hello, students and YouTube learners. Once again, this is Dr. Satish Singhal, PhD, Professor of Computer Science at Camino College, Torrance, California. I'm here with the third video about looping control structure. And in this one, we'll focus on basic prep work to learn about how to code end of file control loop, EOF loop. This is one of the most important loop because industrial strength software uses files to read the data and write to files. Other loops are important to understand the basics, but this loop is the workhorse of the industry. So it's very important from that point of view. Okay. So let's review what we have done so far. In video 1, we covered general principle of looping control structure. In video 2, we discussed the source code and text for a special type of event control loop, which is called sentinel control loop. Our ebook and Tony Getty's book has example of count control loop source code, and page 13 to 17 of my ebook gives source code examples of count control loop. They are easy to grasp. Please review them. Okay, so we did this classification of event control loop. Recall that event control loop is such that an event has to take place inside the loop to change the condition or to reach a special value of the loop condition, which is called termination condition. Negation of when termination condition is reached, the loop test condition evaluates to false. So anyway, we have three types of different event control loops. Sentinel control loop discussed in video 2. Most of this will be discussed in video 4, but in this video we'll basically learn how to work with file, so we can teach you this one. And last will be flag control loop, and we'll talk about that maybe in video 6 briefly. All right, okay. So let's talk about data sources and data persistence. Data sources are where our data are stored. These could be files, databases, and web pages, or even tapes. Okay. Data persistence is that how to make data persist from one program run to another. But so far in this course, we have processed data by entering them from keyboard, and if we needed to output them, we output them to console. Now this technology has limitations. You can learn about things, but industrial software processing is not limited to entering data only from keyboard and only displaying output to the console. Data management and using data for decision making requires data persistence. That means you write the data to files, databases, and web pages, and you archive them. Okay? Just what I said. Data persistence requires storing data in files, databases, web pages, and data warehouses. And do understand that very often this data is huge, voluminous. And voluminous data can be processed very fast with loops, because computers are very good at doing a task repeatedly very fast. Okay. Data archived in data sources must be processed, and EOF loops are central to such processing. Now we'll learn how to read data stored in text files and how to write data into text files. Okay, so that's called working with files. And as I said earlier, before we can discuss details of EOF loop, the next important rule, we need to show how to work with files. So just like our IOStream include allows to input from the data from the keyboard and output data to console, in same manner, number include fstream, F for file, allows reading data from text files and writing output also to text files. So what is the meaning of text file? Meaning of text file is that file is a simple file as created by software such as Notepad, and there is no possibility of fonts, italics, and bold variations. Obviously, they cannot store pictures. Text files can only contain characters that you type on the keyboard. And each keyboard character has a fixed ASCII value. You know that from chapter 3. Thus, such files are also called ASCII files. Okay. So we said that you need fstream and include in order to work with input and output text files. So if I want to write a program that's going to do that, it will have typically these includes. Number include IOStream, that's always required. Number includes string, and that's required to store full file path. So we'll talk about file path in a minute, but in any case, whatever it would be a string. So we need number include string. And then, of course, we cannot do file reading writing without fstream. So we do number include fstream. That's required to read files and write to them. And it has a special facility to bind to the file using its full file path. So this will allow us to store file path, and this will allow a facility to bind to that file and do read and write with that file. Okay, now we need to talk about file path and file name. You could have a computer or a computer network, and often a file would be stored inside one or more hierarchical folders. Hierarchical folders are that you have one folder, inside that you have another one, inside that you can have another one. And that's why you can also see file structure as a tree, with the root being the root directory, which is your root hard drive, folders being branches, and the file name being the leaf. Okay, so you can go from root to trunk to one branch to another branch to another branch. Finally, you read the leaf. We're going to show you a schematic example of directory tree in the picture in this slide right here. So notice here, floppy disk means that this is your hard drive. Let's call that directory C, root directory. Windows very often is called C, although it could be D or E, any other name you like. Then in that you have a subdirectory, which is a folder, subdirectory 2, which is a folder, and there could be just files, file 1, file 2, etc., or file names. Okay, so there could be file directly on the root directory, but then it is possible that inside this folder called subdirectory 2 there are files, and then there's another folder called subdirectory 3, and then inside this subdirectory 3 now I have only files, file 12, file 13, file 14. In this one there is no folder or subdirectory. So let's say I want to work with this file in my computer program. So look at the travel path I have. I go from C to subdirectory 2, folder called subdir2, and then I'm going through this and I go to folder called subdir3, and then finally I reach file 13. So notice this path. This is the full file path. So in that case, I start with C, colon, root directory has to have a colon, slash, Then I go to subdirectory 2, subdr2, and inside that is subdr3, and then I finally reach my file name, which is file 13. So this whole string is the full file path. Now notice I don't have dot extension here. That's not necessary. A file may have extension to really help it to be opened by a particular program. If it doesn't have an extension, you will have to choose a program. So files do not necessarily need extension all the time, as long as you know which program will open them. But important thing here is that how we went from root directory to folder to file, and we start with root directory / first folder, second folder, and the file name. This is called full file path. Okay. And it's very important to know that full file path is a unique identifier for a file. And you know that very well, that inside a folder on a computer, two files cannot have same name. Try it, it's not going to work. So in that case, the full file path to a file is its unique identifier. If you have done a database class, unique identifier in that case is the primary key. So you could in a way say that full path to a file is its primary key. We would need to remember this fact when we ask computer to open a file, either to read it or to write into it. Using the full path to a file and fact that it is a unique identifier to the file allows computer to locate the file on the computer because it's unique. It knows how to travel through from root directory to subdirectory 1, subdirectory 2, and so on to the file. So what I mean is that, let's go to previous slide just for a second. Once I give computer this string, computer knows actually that where it has to travel to locate this file. It will travel exactly the path that I've drawn here to locate and bind to this file. Notice that we keep using the word full file path. That is because there is another file path called relative path, and we will leave its discussion to some future date. Okay, so first I'm going to talk about a minimal file reading program. We're going to go to our compiler and show key parts of a minimal file reading program. This program does the following. It prompts user to enter full path to the data file to be read. It opens the program file. Program opens the file. It just reads one line from the file, and then program outputs the line that was read to the console, and program finally closes the file. And one must understand the difference between file name and file path. Once again, file path specifies the complete location of a file on the computer or computer network. Location starts with the root directory. And file name is just the last part of the file path string after the last slash in the file path. Okay, so I'm going to go to my Xcode now. For that I will get out of here, and Xcode is here, and I have 3 programs there. I'm going to show one at a time. So let's go to our first program. I'm just going to rename it main. And I want to make sure that there's no other main. Main 2 and main 3. They should be main 3. Alright. So I'm going to fold every other program that, so let's unfold this one. So notice we talked about includes. So I have all those 3 includes that I showed you in the PowerPoint. Now we're going to go step by step as to all the steps I mentioned in the PowerPoint, that get the file name, bind it to the, use the fstream object, and then open the file. So these are the steps. It's very important that I'll upload this also, that you understand these steps. So in this program, we'll be reading file and output to console. So first step is store full file path into a string. Now, this is very important to know that file path on Windows and even on Mac, with the exception of Unix, could have white spaces in them. Okay, so white space will be like this. Let me just type here just a little bit. See my folder 1, my folder 2, my text.txt. Notice there is a white space here, white space here, white space here, white space here. If I take input of this string using cin arrow arrow, the extraction operator, only this part will be read. Rest of the path will not be read. That's not full file path. So we have learned about getline already, that using getline you can get the entire string regardless of whether it has white spaces or not. So we must use getline because file path may have white spaces. This is a very serious error, common error made by students not using getline. This will only, not using getline and using cin arrow arrow will only work if file path has no white spaces, and only system that guarantees that is Unix. Most other operating systems allow white spaces in the file path or in the file name even. Okay, so we must use getline. So I declare a file path string, full path, and I prompt user to enter full file path for input file. Input file must exist, otherwise you can't read it. And I use the getline so that I can get all the white spaces. Okay. So line 23, this string contains the full path to input file, which is its unique identifier. Next, we declare a variable of type fstream. Fstream is also called object. What is fstream? Fstream is a piece of software that binds to input file, or it can bind to input file, and it can move through the file same way cin moves through the keyboard data. So I declare fstream and I give it a name. Fstream requires fstream include. It will not work without that. What is in? In just a variable name. In is just a variable name. So when you do keyboard input, the name cin is fixed by the C++ for you in the advance. But for file input, you are free to choose a variable name you like, just the way I chose the name in. And you'll see soon that we'll be able to use the object in just the way you could use cin for reading the contents of the keyboard input. Okay? So we complete the step 2. And then in step 3, we bind the file name full path. We got that one here. to the if stream object in. This binding is done using a stream function called open, which takes the full path string as a function argument. Once it does that, computer knows exactly where to go to bind to your file, and that's because full path is a unique identifier. So it knows the path it should take in order to attach to your file. A cryptic, nonetheless, a description of open function is provided by the link below at c++.com, and you can read it. So now I take my stream object, call its open function, pass it the argument, which is the string that has the full path to the file, which is its unique identifier. Okay. That's not enough. If this string has error in the file path, then I won't be able to open my file, and I wouldn't even know whether I open my file or not. So this is always required, that we confirm and validate that indeed the file has been opened. I want to caution my CS1 class, anytime you work with the file and this is not done, that's a software error. Here it deducts points. If you do that in your software job, that's a lot more serious. People lose jobs by making those kind of errors. Okay. So step 4 is confirm and validate that indeed file is open. This is done by calling the isOpen function of the stream class. If isOpen returns true, then file is successfully open. If it isOpen returns false, then computer fails to open the file. You can go to c++.com and just type in search box isOpen, and you can read more about that function as well. So isOpen returns true or false, and it's called by dotting isOpen with the if stream object in. This dot notation induced function call we did earlier in scene.ignore. So once you have an object has functions inside it. Chapter 3, I believe, described that. Or could be, no, chapter 5 describes that in more detail, how the dot notation function calls are made. But crux is that what we're telling computer that, okay, we have this object that was bonded presumably to a file whose full path is this. Can you go and check that it's open? And isOpen does that and returns true if file indeed is available to be read when it's open. It returns true. And if that's the case, then obviously I can do data processing on the file. But if isOpen returns false, then this is false. So obviously I'm going to fall to the else block. And then I just tell user there was error in file opening. We cannot read the file. Okay. So if isOpen returns true, then my file is open to read. So here I'm going to do bare minimum. Only data processing I'm going to do is I'm just going to read just one line. I don't care how many lines are in the file. To get the whole line, again, I use the getline. Notice the difference in the syntax now. When we were getting data from the keyboard, entire line I use cin, but now I'm reading the file. So instead of cin, I use the in. Now this is the error students make all the time. They'll copy and paste from here to here, and then they will forget to change this to in. And then when you run your program is waiting for you to enter something from the keyboard, and you're saying, okay, how come my program didn't work? How come it didn't work with the file? Well, obviously, if you put C in here, it's expecting data from the keyboard. So don't forget that. When you're reading line from a file, you use in, which is fstream object. If you're reading data from the keyboard, you use cin. So line 56 will read one line from the file using this fstream in object and store that into the variable line. And now I'm just outputting to the console. Okay, pretty simple program. Let's run it. And I'll show you the input file, and I have its path stored in that program, but I'll also show you that's the file path. Quick brown fox jumps over lazy dog, not the path but the one line in the file. And how do I get this path on the Mac? I right click and then I press option and I copy input file.txt as path name. That gives me the full path. I go back to my Xcode. I'm ready now, so I run the program. And I need to show this one. Okay, did. Enter the full file path for input file. I paste the path that I copied. And now if I press enter, since file does exist, this will be true. It read that line, quick brown fox jumped over lazy dog, using getline, and then I'm doing C output line. That means I should, as soon as I press enter key, I should see the words quick brown fox jumped over a lazy dog. So watch this space. Of course in Mac it says, okay, do you want to allow this? Sure, I will allow it. That's a new security feature they put in the Mojave. So just say okay. And this is the same thing that was there in our file right here. Quick brown fox jumped over lazy dog. Of course earlier I showed you in the text edit, but it's the same thing. Okay, so we showed you all the steps of reading a line from an input file and reading it, attaching fstream object to the file, and then outputting to the console. Now I could demo for you the else block. Obviously if I type a name of the file that doesn't exist, then it should output this statement, error in file opening. Just for the sake of completeness, I'll just do that. So I know there's no file called xxx, and it says error in file opening, cannot read the file. So you will get that. So this validation is absolutely required, always required. You cannot skip that. That would be a huge error. Alright, so we completed one of the three programs we wanted to do. So what is our next program? Writing to an output file. So I'll just write something to an output file. We're going to show that also through a simple program in our compiler. We follow the process similar to the one we use to work with an output file. The steps to work with an output file are identical, except this time we are using a different object, offstream. Otherwise everything is same. And we're going to show this also to you in our compiler. Okay, let's go back to our compiler. So I have three programs in the same file. So I'm just going to change the name to main1 here, so that I don't execute this. And this is the one that has program for writing to output file. So I recoded that main rather than main2, and now I want to show you all the steps in this one. Outputting any data to an output file. First step is exactly identical. Actually, all steps are parallel. We store full file path of output file into a string. Output file can also have white spaces, so we must use getline. I create a string called out file out full path, prompt the user to enter the full path, use the getline to store output file name into this string. Now, only difference in this case is if you have an existing file in this path, then it will write into that file. If it doesn't have a file, but you give it a path where file with the same name doesn't exist, then actually program will create a file for you. So output file can be created. Okay. So by the time I'm line 82, the full path to output file will be stored in this one. If file doesn't exist, it'll create it. If file exists, it'll write data into it. This time we declare a variable called offstream. And again, it's an object. Offstream is the piece of software that binds to an output file and outputs data into output file. This does the same way, works the same way as cout outputs data to console. Out is just a variable name. For console output, the name cout is fixed for you in advance. But for file output, you are free to choose a variable name you like, just the way I chose the name out here. Okay? And we'll be able to use the object out just the way you could use cout for writing to console. Third step is bind the file name out full path to the offstream object out. This binding is done using a stream function called open, same type function, which takes full path string as a function argument. And once again, the open function description is given on c++.com. So we open the same way we used in.open. So we do out.open and we pass the string to full path to the output file. You need to do that confirmation and validation just the way we did for the input file. And once again, this is done by calling the isOpen function, which returns true if file is successfully opened. And if isOpen returns false, then computer fails to open file, and then we can give user the message failed to open the file. So we do that validation. If out.isOpen, if this is true, then file is successfully open. And then I can just have a line called quick brown fox jumped over lazy dog, and I can output that to the file. Notice that out object works to write into the file, just the way in object work to read from the file. Okay, and we are going to demo that. But if somehow the drive letter was wrong in the root directory, that means that drive letter doesn't even exist. In that case, isOpen will return false and will say error in file opening, cannot output to the file. Okay, so I'm gonna use a file, output file. I want to make sure there's no data in there. This is the file. Let me open it, and notice it's empty. There's nothing in there. So I want to make sure you do not feel that I have done a trick to you. So let's work with this program. So we'll compile and run it, and I'll get the full path to the output file this time, and I'm just a string that I want. I'm outputting that. Okay, so my file already exists, and I'm going to get its full path. On Mac, full path is right click, press option, copy, and I enter that. And you'll get no message here because it's just writing this string into the file. Okay, so we'll make sure this string is written. So no message here now. Of course, it will ask for permission. Okay, now I go to my output file, open it. Earlier it was empty. Now it says quick brown fox jumps on lazy dog. So we are able to write to an output file using our C++ program. The steps were similar to the case that we did for the input file. Okay, so now if you give a wrong file path, what happens? Well, that's kind of interesting situation, because if you just give any file path, it's supposed to create it. If you just give any file name, it's supposed to create it. Although most of the time you won't know where it did that. But if I give a wrong drive letter, like drive letter doesn't even exist, then it's not going to create it. Then it'll be error, and you'll see this error showing up. On Mac, I cannot reproduce that error for you. Windows, if and when there's a chance, I'll show you how you can do that. Okay, so if you give a file that doesn't exist, it will create it, and chances are you won't know where it created it. So it will actually create it in the same folder in which your exe is. If you go there, you'll see it. So to see this message, you'll have to give it a drive letter that doesn't exist. Okay, we won't worry about that too much. So we have completed all the steps to write to an output file. Okay, so third is how do we combine these two approaches and show how to read from one file and write to another one? Okay, that's our third program. So let's see our third program. So to see our third program, I'm gonna rename it as main2, so I don't run it, but name it as main. This is the one that has how to read from input file and how to write to an output file. Notice that since I'm doing reading from an input file, I cannot there's no need for me to do ask name of a output file unless input file is successfully opened. Anyway, let's see our program. In this one, we read from an input file and write to an output file. You do have option of writing the console as well. So you already know steps up to here. Those were in this program 1. You can look at this again. And so hopefully by now we got the full path to the input file. We call the isOpen function. If that returns true, then file is opened successfully. Now, since my file is opened successfully, actually I should do one more test. That file has some data in it, but we're going to assume that it has some data in it. We'll worry about that issue later. So now we do all those steps for opening an output file, and we have done that also in the program number 2. So we do the same thing, out full path, prompt for that. Using getline, we store it, create an offstream object out or open will open the output file. If file doesn't exist, it will create it. But we still have to validate that we are able to indeed work with the output file. So we call out isOpen. isOpen returns true if indeed I have created successfully an output file. Then now I read a line from the input file in line means getline will get the whole line, but this time I use the object out, which is bonded to output file whose name is here, and then obviously it should print that line to the output file. If this is there, writing is not going to give me a message on the screen. But if somehow wrong drive letter was given, then else block will execute and it will say error in file opening. I guess in previous program I skipped a step called you must close the file. Break the bond between file out object. This else block binds to this one. That means just in case I couldn't open the input file. And then I say error in file opening, cannot read the file. This step is very important, by the way. I missed that in the first program. You should always close the file because file hogging may deprive other people from using that file. So this last step of closing files, whether you have input or output, is extremely important. So let's run this program where we are reading from one file and writing to another one. And I'm going to show you both files one more time so that you're convinced that everything is fine. So input file has this one line, quick brown fox jumped over a daisy dog. Output file had that line. I'll delete it and save it. So let me delete it. File save. It got saved. Okay, one more time. Empty. So whatever was input file should show up in the output file after I run my program number 3. So let's see that. So let's run my program number 3. We read from a file and outputs to an output file. Okay, so I'll get the path to the input file one more time. In Mac, right click, press Option, got the full path, and I copy and paste it. And it will ask me to allow. Okay. Now it asks for the output file, and I'll go to my folder again on Mac, right click, press Option, get the full path. And you give it that. It asks for the permission again. Actually, it didn't ask for the permission this time because I think I already given permission the first time. And now the output file that is empty should have quick brown fox jumped over lazy dog, and there it is. Okay, so this pretty much completes the whole picture of 3 situations: reading from a file, outputting the console, simply just outputting something to an output file, and reading from an input file and writing to the output file. That's the most important one. Okay. All right. So let's conclude this video. This concludes our loop control structure video 3. We built up the knowledge base about type of files to read and write and mechanics of how to work with files. And video 4 will discuss EOF loop theory and maybe just one simple EOF loop, okay, which would be very similar to program 3 we just did. Okay, good luck, and this is Dr. Singhal saying goodbye from Looping Control Structure video 3.